Hello guys and welcome back to CS with Mr. G. Today we are starting a new unit of work, which is unit number 9, and this is all about databases, where today we will go over the absolute basics and some of the fundamentals behind a database, including all of the keywords that we need to know when it comes to a database and the data types that are involved, which are very similar to the programming data types which we've covered already. So as you can see, we are currently here nearing the end of our full iGCSE computer science course, and the database unit is fairly small as the requirements of database knowledge for iGCSE are quite simple, and we can probably cover it in probably a few lessons, which will allow us to build a foundation of database knowledge if we wanted to explore that field further. So to start off with, we are going to look at this term single table database just for today, where we will look at a database consisting of a single table. So we need to know what a table is and what's inside a table. We will also look at the basic data types that we can use in our tables, which, as I've mentioned, is very similar to programming, but there are a few differences which we will cover today. Then we have this term primary key, where we need to be able to identify a suitable primary key given a certain scenario and an example database to work with. So to start off, we are just going to look at the definitions of a database and why we use them, and they are literally just a way of organizing and managing information, as you can see in bold here. But if we've got any type of information stored somewhere and we want to be able to organize and manage it, a database is a perfect place to do so, as we can manipulate the data to our needs. For example, in the scenario here, imagine you have a massive list of all your favorite films where we have stored the title of the film, the director, the year it came out, and the rating of the film. If we had all of this in one huge list, for example, written down on a piece of paper or even in a text file such as a Word document, it would be very hard to search through this list, and we certainly wouldn't be able to sort it in any way, for example, in alphabetical order of the name or in ascending order of the release year. If it was simply written down in a list, we would not be able to do any of these types of things, whereas we would if it was stored in a database. So a database offers us some kind of structure which makes it easy to sort and filter through our information, and it also makes it easy to add further information, update existing information, and find specific information stored inside of our database. So just very quickly, we'll go through why we use a database. I have seen this question before in the exam, and it's very important to know why we use databases in case these types of questions come up. Well, first and foremost, the organization aspect to a database comes back to this word table. By storing information in a table allows us to keep it nice and organized and makes it easier for us to understand and work with, especially when it comes to large amounts of data. But these terms, rows and columns, are something that we're going to look into in a little while, but these are the fundamentals when it comes to a table, which you will see shortly. We can also talk about the speed, and when we're talking about speed in a database, we're talking about searching through information, sorting out information, but in general, just working with data inside of a database. We are able to do things much quicker than if it was in just one list or in a Word document, for example. We've also got this aspect of security. Data inside of a database can be protected, and if it's a large database that has multiple users, which we'll come to in a minute, we can protect certain parts of the database from certain users depending on the nature of the database. For example, in a school database, certain information can be blocked from the students, whereas the teachers might be able to access it. So that's just one example, but like I've mentioned there, the fourth point, multiple users. Databases can be used with many different people. If you think of any online shop or any social media website, there are millions of users at one time, all accessing the databases provided by these companies, and we are able to do so because the data is stored inside of a database. And finally, this term consistency. By using a database, it makes sure that data stays consistent. We can make sure data is stored in a specific data type, and we can also apply certain validation rules, which we've mentioned before, to make sure data is validate, and again comes back to this word consistent, so data stays the same throughout the database, which will help with all of these points, keeping it organized, allowing us to work quickly with it, and keeping data secure. So this word consistency is also crucial when it comes to a database. So how they work is simply using tables. And there are a few keywords that you can see here that are really important for us to know when it comes to understanding databases, particularly if you are going to work with them in the future. Now, first and foremost, every table inside of a database has a table name. And in this example here, we have a table name called cars. So our table contains data about cars. And as you can see, across the top, we've got our fields, and we have 3 field names, which are make, model, and year. So across the top, we have 3 fields. And then going horizontally, we have a record where each field is filled in with some kind of data, which in this example, we have the make of a car, we have the model of a car, and the year that the car was made. So the records are essentially the rows, and the fields are essentially the columns. So as you can see, a record is a single row, and the easiest way that I can remember this is that record begins with the letter R, and so does the word row. So if you ever get confused about a record and a field, just remember that the word record begins with the letter R, and a row also begins with the letter R. So as you can see, one record refers to the whole row, which in this case I have highlighted a Tesla Model S released in 2021. A field, being a single column, represents one specific type of information, and for each field we can apply certain validation rules to make sure that data is entered in a certain way. For example, in this model field, we can make sure that it contains text, and we could limit how many characters are typed in for this field. But obviously, when we discover bigger tables with more types of information, we can then discover more validation types, knowing which ones to use and when. So here we have our list of data types that are available in databases, and as you can see, a lot of them do overlap from our programming unit. In particular, text or alphanumeric we have referred to as a string in units 7 and 8. We've also referred to a character or a char, which is a single character, and again covered in our programming unit. Boolean, also covered in programming. Integers, whole numbers, we should know this one. And then a real, also known as a float, are decimal numbers, which will be a number that includes a decimal point. And then finally, a little different to programming, we actually have date and time as a specific data type, where we can declare a field itself as a date and time to make sure that data is entered in this format. And again, we will see many examples using this data type in the future. So now that we know what a table is and what a table consists of, including fields and records, something else that is vital to a database in keeping it organized and consistent is this use of a primary key. So primary keys are fundamental when it comes to databases, and all a primary key is a unique identifier for each record in a table. So we have to pick one of the fields, which if you remember, a field are the columns, and we need to pick a column that we can assign a unique piece of data for each of our records. So in this case, we've got a list of authors in our authors table, and although each name is unique, so these 3 names here are all unique, and their birth years are also unique. If I was to add a 4th author, technically we could have an author with the same name as one of these 3 listed here. We could also have the same birth year, as there were many people born in these years. So although they are unique in this example, it'd be a much better idea to use this ID number here, as we know we can just assign the next available number, which will definitely be unique, as a primary key to ensure that each record has a unique key, just in case there were 2 authors with the same name. If we think back to a school, for example, in a school there is a good chance that there are 2 pupils with the same first name and last name, and it's not impossible that they were born in the same year as well. So it'd be a much better idea to give them an ID number, like in this case the author ID, and then we can uniquely identify each record, which again helps with keeping data organized. So if we were to expand this database of authors to have a table that includes books, we've got a separate table which is called books, and as you can see, we now have 4 fields. Got the book ID, the title of the book, the author ID, so the author who wrote the book, and the year the book is published. Now again, even though the title of the books are unique in this case, and so are the years published, it's pretty clear that the book ID is going to be the primary key in this example, just so we can make sure each book has a unique reference number. If you notice that the author ID has been repeated, that's fine, because the author ID in this table is not the primary key. The 2 books that have been listed as author ID number 1 were both written by J.K. Rowling, which are both Harry Potter books, and this is completely fine in a database. And when we do this, what we actually call this is a foreign key, because the author ID in the books table is actually a primary key in the author table, which we listed earlier. So when a primary key appears in a separate table and is repeated, we refer to this as a foreign key. And what this does is it builds a relationship between the 2 tables using these 2 keys. And again, this is a fundamental technique when it comes to database design, and something that you will get used to the more we explore databases and see more tables. But for now, just as long as we understand the terms primary and foreign key, that's all I want you to take away from this lesson. And something else we've also covered in units 7 and 8 when we covered programming were the types of validation listed here. So if you aren't familiar with these terms, please go back and watch the video on validation in Unit 7. But something that we can do in a database is validate data to make sure that data entered follows all of these types of validation to again make sure data stays consistent and is entered into our tables just how we want it to keep data organized. So in the example that's different to programming, which was the date and time data type, we can specifically ask the user to type in the date and time in a set format so that there's no mix up between the days and the months, for example, and that 4 digits digits are entered for the year. But again, it all comes down to making sure data stays consistent throughout the database, and is the same when it comes to different records. So just to finish off in this introduction to databases, I'd like you to try and fill in the gaps. So give the video a pause and try and give it a go, or likewise just follow along. So a database is made of at least one table, and each table consists of many fields, and then every record has the same number of fields. If we think back to our car example, there were 3 fields for each car, and then every field is given a data type. Examples of data types are text, char, and boolean. There were more, but I've not listed them here. And then some fields will have validation rules. So there is the completed task. I just want to flick back to the learning objectives before we finish, and hopefully now we can define a single table database, knowing that it consists of fields and records. We've looked at the basic data types included in databases, and we've also explored this term primary key and foreign key, and hopefully we can understand the use of the primary key when it comes to a database, so that as we move forward we can start to build relationships across multiple tables and allow our databases to grow and store more information. So just an introduction for today, guys. Hopefully that's made sense. In the next video we will step it up and look at more complex databases, but hopefully you've managed to follow along, and I hope to see you in the next video.